Hey, welcome back, my amazing student. So this is the Python mentor here, making really complex stuff really easy to understand. And in today's lectures, we're going to talk about mutabilities and copy. So in Python, sometimes when we are starting out, and especially in programming, we think that we are creating a copy of something when we create an assignment. When we assign a list of items to another list, we're thinking we are creating a copy. And in reality, what we're doing is we are just assigning that same space in memory to that new variable. That's basically what we're doing. So a mutable object in programming can be changed in place without creating a new one. Let me repeat that again. A mutable object, when something is mutable, can be changed, all right, without creating a new one. So in simple terms, if something is mutable, you can modify its content. You can add, you can remove, you can update items, and still is the same object in memory. It will still have the same memory address. Crazy hexadecimals like this, right? Now, when something is the opposite, when something is immutable, all right, immutable, all right, that means any change that we make, all right, creates a new object. Now, let me show you some of these examples here of mutable objects. Something mutable can be lists. Lists are mutable. Dictionaries are mutable, okay? Now, when something is immutable, strings, tuples, something like this, in numbers, those things are not, we're not able to change this without creating a new one, all right? Every time we try to make all this a different one here, we're going to create a different memory address. For this here, we can change it in its place, and it's going to keep the same memory in the memory address, all right? So let me show you just a quick example here, and I already have it on my clipboard, so I'm just going to paste this here, all right? So this ID function is just going to give me the ID of this this object in memory, all right? Python's doing that for me because the programming language loves me, and I love the programming language. But anyway, I'm just joking. Let me just clear this out so that way you can see it. So you can see now that we have the product's ID, that big list, that is the ID, right? And now we have all these references inside that list, and we have their IDs as well, okay? Now let's do an assignment here real quick, and let's see what happens, right? So some of us beginners, right, we think that when we are creating an assignment, when we are assigning a variable like this to another one, we are creating a copy. In reality, it's all the same in the same memory address. So let's go ahead and run this, and you'll see. And you can see now this is the original products right here. We got the same ID for the products list, and the same reference IDs for those items inside that list. Same ID, all right? Now let's modify our inner value, and let's see what we get. All right, so what I'm gonna do is here, we're gonna be modifying an inner value here just to show you some examples here on what's going on, all right? So the inner value that we're gonna be modifying is milk here, and we're gonna be modifying this and creating organic milk out of it, all right? Then we're gonna be printing out those values here, those IDs, so that way you can see them. Now, don't worry too much if these IDs actually change, like generally for the whole thing, because these IDs are being produced dynamically, right? Those reference in a memory are gonna be the same no matter what. These IDs are just being produced dynamically, all right? So let's go ahead and run this. Let me come back here, save this, and run this. All right. Notice that the products list has the same ID right here, right, as the copy A ID. The same, these IDs are the same, right? Nothing has changed, and I'm pretty sure, and if I go ahead and print this out, the inner items are gonna be the same as well. The IDs of these inner items are gonna be the same. Now, let's go ahead and make what we call a shallow copy, because only the outer layer will have a different ID, and you're gonna see this in a minute. So let's go ahead and run this. So right here, what we're doing is we are using the copy module. Go ahead and import this on top here if you wanna see it. Okay. Now this is just going to produce a different ID for the outer layer, all right? and then it's gonna keep everything the same. All the inner items should be the same. And you can see this in the shallow copy, you have the ID here, all right? The main ID, the outer ID of the list is different than this here, right? But the inner items have the same ID. Okay, so nothing basically has changed here, only the outer layer here. If you want to make a real object, a new reference in memory, you will have to do something else. Let me show you. You will have to create what we call a deep copy in Python. So now with this module here, what we can do here, and this is just for demonstration purposes. Remember that I'm actually referring to immutable objects here and immutable objects, right? So when we have a mutable object, we can change, the object can change in place without creating a new one. Remember that, okay? Immutable is when you have any change that actually creates a new object. Now we are talking here about lists, all right? List is a mutable object. Okay, so we can change the list without creating new references in memory. Now, here's the deal. We are actually creating something forcefully here. All right, just for you guys to understand. We are grabbing a list here and creating a new object, a new reference in memory out of it. Right, and this is basically, I'm hacking this a little bit here so that way you guys can understand. I'm grabbing a mutable object here. All right. And creating basically an immutable feature, all right? So that way you guys can understand what the difference between copies, real copies, and fake copies, all right? Or shallow copies, or direct assignments like we have been doing here, okay? When we grab a list here and assign something, it keeps the same memory reference and that same address in memory, okay? Here is the only way that we're going to be creating something brand new in memory. So save it, run this, and now you can see that after modifying the copy, we have a different ID here. Look at that. We have a different ID after using that deep copy module or the copy module completely. And not only that, but we have a different ID for the inner items. Notice that the inner items in this one here are all the same. Okay, not in the deep copy. In the deep copy, we have a different address in memory now. Is a new object completely. So I hope that you guys have an idea, at least a good idea, all right, what direct assignment actually does, what the shallow copying actually does, and what deep copying actually does or is. All right, guys? Anyway, guys, thank you so much for watching my videos. If you like it, if you are able to understand this a little bit, give me a like. That motivates me to create more videos here, making really complex stuff easy. I'll see you guys on the next following lectures.